Hello everyone, welcome to my channel VTU Brains. Today we're going to discuss the important questions of the subject code BESCK204C or BESCK104C, Introduction to Electronics and Communication as the subject name. So let's discuss module 1 and module 2 first. And let me tell you that these both modules are based on circuit diagrams, and mostly it deals with circuit diagrams. You need to be very perfect with them, and to get full marks you need to draw them perfectly. Okay, because theory is also important, explanation about the circuit diagrams are also important, but first preference will be given to the circuit diagram and how, if you have drawn it correctly. So make sure that you be perfect in all these questions that I'll mention today. First question is, what is regulated power supply? Write neat block diagram and explain the individual blocks. Also mention the principal components based in each block. This is like almost like in every paper this question will be asked, so it's very important question. What is rectifier? With neat diagram and output waveform, explain full wave bridge rectifier with capacitor filter. So this is asked with capacitor filter. They might also ask without a capacitor filter, so you just need not draw this then. Okay, and even half wave rectifier can also be asked at times, but usually it's always full wave bridge rectifier or full wave rectifier. Okay, so this is an important question. All these questions have already occurred in the previous years, and they are also important questions given in internal question papers, and I've collected from various sources from the internet as well. So yeah, you can rely on it. Then the third question is, what is an amplifier? Explain the types of amplifiers. Fourth one, what is voltage multiplier? With circuit diagram, explain the operation of voltage doubler. Next question is, what is voltage regulator? With neat circuit diagram, explain the operation of a voltage regulator using Zener diode. It's also a very important question. Mention the advantages of negative feedback in amplifier circuits. With relevant equations in diagram, explain the concept of negative feedback. This is also repeated many times. So all of these questions, all of these are very much important, so you need to cover all of these compulsorily. Moving on to module 2, explain Barkhausen's criteria for oscillations in Wien bridge oscillator. So these are the conditions. This is a numerical problem based on Wien bridge oscillator, and you need to find out the frequency of oscillation. So the thing is, this was also asked many times in the previous year question paper, almost every time, except the paper that I have attended. Okay, so that time this question was not given, so there is high chances of it occurring this time. So it's better if you learn this. It's very easy numerical once you learn it. And here in this this was also asked in another previous year question paper, so there they have just changed the numbers and they have given it. Okay, so I've given you both the types. You need to practice these both, then it's enough for you to, it's fine for you to be perfect in this type of question. Okay, learn the concept and learn how you will solve it. Next, moving on to the next question, explain the operation of 3-stage ladder RC network oscillator with new circuit diagram. This is also a very important question. It is like super important. Explain operation of single stage stable multivibrator with its circuit diagram. And define op amp. List out the ideal characteristics of op amp and parameters. Okay, so parameters, they can ask characteristics, and you need to define it. Sketch circuits of each of the following based on the use of op amp along with the input and output waveforms. So an integrator, voltage follower, and a comparator. Okay, so this is also very much repeated question. On to module 4. Now let me tell you beforehand that module 4 and module 5 are both theory based modules. So if you're more inclined towards theory and you're good at theory, then I suggest that you do module 4 and 5 first. Keep those as your main prime focus. So both of these modules will be your passing modules, and then focus on module 1 and 2. Okay, now first question in module 4 is, what is an embedded system? And compare embedded system and general computing system. This is easy, and yeah, it's also very important. Classification of embedded systems and its applications with example. So you need to classify embedded systems. Okay, so this can be asked, or they can just also ask you to write the applications of embedded system with example. Okay, so you need to be prepared for both the types of questions. And third question is, what is the difference between RISC and CISC processors? Okay, RISC and CISC processors. Explain how 7-segment LED display can be used to display data, and write a brief note on operation of LED. This can be asked, or they can just they even ask like this. They've already asked. Okay, write short note on 7-segment LED display. Then next question is, write a short note on transducers, sensors, actuators. All these three will be asked at once, right? Short note on these three. Then next question is note on core of embedded system with block diagram. Okay, so then yeah, that completes our module 4. Moving on to module 5. With need block diagram, explain modern communication system scheme. Then next question is note on hardwired channel and soft-wired channel. Third question is explain with a need diagram the concept of radio wave propagation and its different types. It's very interesting and it's an important question as well. Fourth question is explain multiple access techniques. Fifth question, list out advantages of digital communication over analog communication. This is very, very, very important question. Then next question is what is modulation? Explain amplitude modulation AM and frequency modulation FM with neat waveforms. So waveforms are very important here. Even in module 1 and 2, like you will have to draw, especially in module 1 you'll have to draw many circuit diagrams where waveforms must be mentioned. Many of us tend to forget to draw the waveforms, but don't do that or else you will lose marks. Next question is explain the following with the help of waveforms. Again, waveforms in ASK, FSK and PSK. Okay, that's also a previous year question. Next, module 3. I have kept this in the last because this deals with lots of calculations with 1 and 0 and it's not theory based at all. So but if you're more into this, then you can also prioritize this module. Anyways, let's start. First question is state and prove De Morgan's theorem with truth table. This is repeated almost always except during my question paper. Okay, then next question is implement full adder circuit with its truth table and write the expressions for sum and carry. This is also a very important question. Then third question, subtract using tens and twos complement method problems. Okay, so all of these are previous year questions. Okay, so here in tens they have given m and n, so you need to subtract this in tens complement method. Another way they have asked the question in a different previous year question paper is they've given the number here. Okay, so one number minus other, so here it's already clear, but here they've given the minuend and n, so you need to decide what number you're going to take and what you need to subtract. You need to know this beforehand. Okay, then in twos complement they'll be given two types of questions. Okay, then fourth question is mention any three theorems of Boolean algebra and prove each of them. This was asked in previous year question paper. Then fifth one is conversions. Okay, so in conversions this is like a pakka question. They'll always give this where you need to convert hexadecimal to binary, decimal to binary, hexadecimal to decimal, decimal to octal. So this is the pattern that they have followed always, but you need to be thorough with all types of conversion, but compulsorily these you have to learn. So here I've covered all the questions that they have given in previous year, which include all of these. Okay, so here these are the conversion questions. Okay, where you're converting from hexadecimal to decimal, then decimal to binary. Okay, then binary to octal, decimal to hexadecimal, again hexadecimal to binary. Here you need to convert from decimal to binary. Okay, so these are given. Then even here this was also given in previous year question to compute one's complement of this number given in binary and compute 9's complement of 0.3267 in decimal. Okay, it's given in decimal. So ones and nines complement is also important as much as tens and twos, but this can also be asked. Obviously you never know how the question paper will be set. Okay, similarly like the first one, even this is the conversion problem, so you need to practice these questions compulsorily. Practice them, has been asked these many years. Now perform the following. So you're going to perform ones and twos complement method for these numbers, and then you're going to perform nines and tens complement method for these numbers. Okay, so now you see how it can be asked. Okay, just a while ago I showed you they have asked tens and twos complement. Okay, and here they have asked ones and nines complement. Okay, in the above question, but here they have asked ones and twos, nines and tens, so they can just ask any method and you need to be ready to solve it in that method. Okay, so if you have watched this video till the end, then I just request you all to study all of the questions that I have mentioned in this video, and you'll definitely score good marks. Okay, so if you watch this till the end, then don't forget to like this video, share this with your friends, don't be shy, and subscribe to my channel to support and for more such videos. I hope this was helpful to you, and if you liked it, then do let me know in the comments below. Okay, thank you for watching. Bye.